Today we'll be looking at vectors in R2 and R3. So when looking at our vectors in R2 and R3, we can look at points and vectors in R2 first. So in the following diagram, OP, so OP is right here, can be represented in component form by the vector defined as AB. This is a vector with its tail. So its tail is at 0, 0, and we're going to call it tip, is at P, which is AB, known as the position vector. Perpendicular lines have been drawn from P to the two axes to help show the meaning of AB in relation to OP. A is called the X component, and B is called the Y component of OP. Again, each of the coordinates of this point is a unique real number, and because of this, the associated vector OP has a unique location in the XY plane. So if we're then talking about our points and vectors in R3, it is useful to represent points and vectors in 3 dimensions, denoted by R3. We label the axes as X, Y, and Z. There are many different ways to choose the orientation of the axes, but we generally use the right hand system with the origin denoted by 0, 0, 0, 0. So this diagram is what we refer to as our right-hand system. So recall our right-hand system, we have a positive X or Z axis here, which is our thumb, and then with our pointer finger, that is our X, our positive X axis, and then our middle finger is our positive Y axis. So if you're looking down at your hand, you have your thumb up, point your pointer finger straight, and then point your middle finger to the inner part of your body, so the inside, alright? So then you have your 3 axes, your X, Y, and Z axes. So, just a note here, the XY plane is determined by the X and Y axes. Similarly, the XZ plane is determined by the X and Z axes. And the YZ plane is determined by the Y and Z axes. And each plane extends to infinity in all the directions. So you notice here we have a diagram of what our planes actually look like. So you have your X plane here, then you have your Y plane, and then you have your Z plane. So note that you can see where your XZ planes are here, because your XZ plane refers to your X and Z axes, and your YZ plane as well, which is labeled. So in our first example here, we want to, each point P, A, B, C in R3 has its location determined by an ordered triple. In the diagram, the positive X, Y, and Z axes are shown such that each pair of axes is perpendicular to the other, and each axis represents a real number line. We want to determine the coordinates of C, D, E, and F. So how can we do that? Well, let's go ahead and show you. So let's first look at our C and find the coordinates for C. So what we're going to do is we're going to look at how do I get from my origin to point C. Well, this here, okay, is my x-axis. It should have been labeled. Okay, that's my x-axis. Here you can see my z-axis and my y-axis. So from my origin, I want to get up to C. So what I'm going to do is I'm going to move out to A. Alright, so far I have A, okay, because you do your X, Y, and then Z. Then I look at, do I need to move left or right at all to get to C? No, I don't need to move left or right at all, so I don't need to move on my y-axis, so it's 0. Then I look at my z-axis. I still need to move up from point A to C, and moving up to C, and because I have my point here, P, A, B, C, alright, I know that my Z value is C. So my point C is equal to A0, C. Similarly, let's look at D. So D here, starting at my origin, okay, we're going to start at the origin once again. Now, do I need to move on my x-axis at all? No, I don't need to move at all. Do I need to move on my y-axis? No, because I just want to get to D, which is directly vertical, our origin. So again, y is 0. But to get from my origin to D, that value, okay, we've moved up C units. Now let's look at E. So how can I get from my origin to E? Do I need to move on my x-axis at all? No, since my origin is at the back of my shape here, my rectangular prism, I don't need to move whatsoever back or forward. So my E, okay, my x value is 0. Now, I want to get to E. E is all the way over here. So I need to move over, okay, to the other side of my shape here. So I've moved over B units. And now, am I at E? Nope, I still need to go up. So I have to go up C units on my z-axis. And then for F, our last point here, to get to F here, alright, to this point, we just need to stop one before going to E. So I know it's 0 for my x-axis, B for my y-axis, and then we're at F. So then 0 for my z-axis. Okay, in our next example, in the below left diagram, the point P, 624, is located in R3. What are the coordinates of A, B, C, D, E, and F? And then in part B, we want to draw the vector OP. So we need to start first with our A. Okay, let's find our coordinates for our point A. Again, we're starting at our origin. A is located right here. So I need to start at my origin. I need to move out on my x-axis here. Okay, just also so you know, this is our p-value right here. Okay, our upper level. So to get to A, all I need to do is move on my x-axis, and I know to get from the back of my shape to the front of my shape, I'm going to move 6 units. So 6, 0, 0. Now B. So to look at starting from my origin, I want to move to B. So B is at the front, so I need to move 6 units forwards, okay, so which would bring me to my A position. And then I need to move from my A to my B. So I need to move on my y-axis, and therefore I need to move 2 units. And that comes from our point 624. and then I'm at point B, so I don't need to move on my z-axis at all. Now C. C here, so always start with your x-axis. C, okay, is at the front of our shape. So our first step is to move from our origin to A, so we have our 6 units. Then from my origin, I can move straight up from A to bring me to C. So I don't need to move at all on my y-axis, I just need to move vertically on my z-axis. So we have 6, 0, 4, because again, our 4 comes from our point P, which is 6, 2, 4. Now we can look at D. So starting again at my origin, D is located, okay, right here. Okay, that is D. So D is at the back of my shape. So I don't need to move at all on my x-axis. And it's on the same side as my origin. So since it's on the same side as my origin, I don't need to move at all on my y-axis. All I need to do is move up vertically, straight up, on my z-axis, and I need to move up 4 units, which will get to point D. Now E. Okay, E here, again, I don't need to move at all on my x-axis, so 0. Now do I need to move on my y-axis? I do need to move on my y-axis because my origin is on the left-hand side of my shape and point E is on the right-hand side. So from my origin, I'm going to move over to F. Okay, so I've moved over 2 units. And now I need to move up to E. So I'm at E now. And that means I need to move up vertically on my z-axis 4 units. And F. Now to get to F from my origin, only thing I need to do is move on my y-axis 2 units. So at 0, 2, 0. And then our last step for this example, we want to draw our vector OP. So when we want to draw the vector OP, we start at our origin and we go up to P. Okay, so that is our vector OP. So now let's continue looking at our next example. So the next example in the above right diagram, the point T is located in R3. What are the coordinates of P, Q, R, M, N, and S? And then we want to draw our vector OT. So again, very similar to our last example, it's just we have a different point. So let's begin by looking at point P. Again, start with your origin. Now, P, do I need to move on my X at all? No, but I do need to move right on my Y-axis to get to point P. So since I know my point T, and my point T is -3 to -2, I know all I need to do here is move 2 units right on my y-axis. So my point P here is 0, 0, 2, 0. Now point Q. Point Q is down below. However, my origin is right at the front of my shape here, and Q is right at the front. So I don't need to move at all on my x-axis, so I have 0. I do, however, need to move on my y-axis, so that would bring me over to point P, so 2. And then I need to move down to Q. And when I move down to Q, that is -2 on my z-axis. Next point we can look at is R. So R here. R again is at the front of our shape here, so I don't need to move at all on my x-axis. It is on the same side as my origin, so it's on the left-hand side, so I don't need to move on my y-axis either. However, it's right below my z-axis, or sorry, right below my origin on my z-axis, so it's going to be moving down -2. So my point becomes 0, 0, -2. Now let's look at point M. Point M, as you can see, is at the very back of our shape. So on our x-axis, we're going to move backwards. And you notice here our t value is -3, so that makes sense because we're moving back. We're not moving forward. So our x-axis for M is -3, and we've now reached point M, so we don't need to move on our y or our z-axis, so it's just -3, 0, 0. Now what about point N? So N here is at the back, okay, of our shape. So again, from my origin, I need to move back, which is going to first bring me to point M, so -3. Now, point N is directly below point M. So therefore, I know I don't need to move left or right at all, so I don't need to move at all on my y-axis. So that is 0. But I do know to get from M to N, I need to move down. And that down is -2 units on my z-axis. And then we can look at S. So we start at S, we start at our origin like always. Notice S is at the back, okay, of our shape here. So we're first going to move back to M. So we're moving -3 units back. Now we're going to move right to S. So our y value is 2. And then, do we need to move at all from there on our z-axis? No, we don't need to move up or down at all, so that is just 0. So then, our last step here, we can draw our vector OT. So starting at O, you want to go down to T, make sure to draw your arrow on there, and there's your vector OT. So we will continue on here, looking at our next example. So for our next example, the point Q, which is located at 2, -3, -5, is shown in R3. So I can highlight here for our Q is 2, -3, -5. Now, what we want to do in part A here, we want to write an equation for the xy plane. Well, when we're talking about the xy plane, since x and y are any real number, we know that z will be equal to 0. So this happens anytime we're talking about an equation for our xy plane, and if x and y are any real numbers, z will just be equal to 0, will be your equation. Now B, we want to write an equation for the plane containing the points P, M, Q, T. So let's look at that plane. So P, M, Q, T. So this here is our plane. So when talking about this plane here, we need to look at what is in common. So look at our x values. So we have 0, 0, oh, then we have 2 and 2. So those aren't in common. Okay, let's look at our y's. -3, -3, -3, -3. Those are in common. But let's look at our z's just to make sure here. So z 0, 0. Oh, we got 2, -5. Oops, and -5. So those aren't on the same plane. So the plane that they share is y equals -3. So when it asks to find an equation for the plane containing a certain points, you want to look at what plane they have in common. And now C, we want to write a mathematical description of the set of points in rectangle P, M, Q, T. So that was looking at the rectangle that we're talking about, the equation of the plane. So we already know for C that y is equal to -3. Then we want to state that x is between 0 and +2, and z is between -5 and 0. And then for D here, what is the equation of the plane parallel to the xy plane passing through R, which is at 0, 0, -5. So that's that point down here. So since we have 0 and 0, so that's just our xy could really be anything, but we know that z needs to be equal to -5. So that is our equation of the plane parallel to the xy plane here. Now, in our last example, we want to draw the points P, which is located at 3, 5, 7, on one set of x, y, z axes, and the point Q, which is located at 3, -4, -5 on another. So what I'm going to draw first here, okay, is my x, y, and z axes. This is my x, y, and z. So now I want to get to writing my point 3, 5, 7. So what I'm going to do is I'm going to first look at, okay, let's first look at where the point 3, 0, 0 would be located. So I'm going to do that. So first, this here would be 3, 0, 0. So I know I need to move out, positive. Then I'm looking at, okay, let's just look at on our y-axis. So let's look at the point 0, 5, 0. So that point would exist, say, right here, 0, 5, 0. And then let's look at, okay, what about the point 0, 0, 7? So just the point on our z-axis. So that point would exist somewhere up here at 0, 0, 7. So now I have my points here. So I know now I can draw in my diagram because I know I need to get to the point 3, 5, 7. So first I'd move out, okay, to 3. I'd move over to the 5. And then I would move up 7 units. So this here would be my point P, which is located at 3, 5, 7. I can draw in the rest of my diagram here. I'm no artist by any means. Okay, and one more line there. So there is our rectangular prism with point 3, 5, 7. So now let's do the similar thing as we did before here. For point Q at 3, -4, -5. So what I'm going to do here, since I know it's going to be +3, but then our y is negative, so I know I'm going to have to go left, and my z is -5, so I know I'm going to have to go down. So I'm going to have my z-axis here, okay, so this is z. I'm going to have my y-axis here, this is y, and then I have my x-axis coming out, okay, which is here. I could continue drawing my x-axis backwards, but I don't have any negatives, so I'm just not going to draw it right now. So since I want to plot the point 3, -4, -5, my first step is to plot our points just on our x-axis, y-axis, and z-axis. So this here, okay, I'm going to label that as my 3, 0, 0 on my x-axis. Now looking at our y-axis, so 0, -4, 0. So from the origin, you're going to move over -4. So you're moving left in this case. So 0, -4, 0. And then on my z-axis, I'm going to move down -5. So that point is 0, 0, -5. Now, to get to my point Q, I know I need to move over 3, out 3 on my x-axis. Now I need to move left -4. And then I need to move down -5. So that point there, I'm going to move down, okay? And that point here is going to be my Q, which is at 3, -4, -5. So now that I have my point there, I can draw in my diagram. So I just have to draw in my rectangular prism. Again, no professional artist here, but it looks okay. So that's my rectangular prism, and that's the lesson for today.